Welcome to qnawire.
To solve this question, we have to apply Newton's second law and discover what is the normal force, because what the scale can measure is the normal force. So the normal force is what the question is calling the apparent weight. Then I will choose this reference frame to solve both A, B, and C. Then it goes as follows. Newton's second law tells us that the net force on the y-axis that is acting on the person is equals to the mass of the person times the acceleration of that person. In this situation, the first one, the acceleration is pointing upwards, okay, and then the net force in the y direction is composed by the normal force and the weight force. Remember, I'm applying Newton's second law to the person, so the tension force doesn't count because it acts on the elevator. So it goes normal force minus weight force is equals to the mass of the person times its acceleration. So the normal force is given by the weight force plus m times a. Remember that the weight force is given by m times g, so that the normal force is given by m times g plus m times a. So we can factor out m to get m times g plus a. So in this first item, remembering that g is approximately 9.8 meters per second squared, we get a normal force given by 95 times 9.8 plus 1.8, which results in approximately 1100, or we can write it as 1.1 times 10 to the third newtons. This is the answer for the first item. Now, for the second item, we have a constant velocity. Constant velocity implies zero acceleration. Then, Newton's second law tells us that the net force in the y direction is equals to the mass times the acceleration, but the acceleration now is zero. So we have that the normal force minus the weight force is equals to zero, and the normal force in this situation is equals to the weight force, which is given by m times g, so 95 times 9.8, resulting in a normal force of 931 newtons. This is the answer for the second item. Now, for the last item, we have a downward acceleration of 1.3 meters per second squared. So the second law tells us that the net force in the y direction is equals to minus the mass times the acceleration, because now the acceleration is pointing downwards to the negative direction of my reference frame. So the normal force minus the weight force is equals to minus the mass times the acceleration. Then the normal force is given by the weight force minus the mass times the acceleration. Remembering that the weight force is given by m times g, we get a normal force of m times g minus m times a, and finally factoring out m, we get m times g minus a. And this results in 95 times 9.8 minus 1.3, which is approximately 808 newtons. And this is the last answer of this question.